Today's question is, how many prime numbers are there? Clearly there are a lot. 2, 3, 5, 7, 11, the list keeps on going. So you might ask yourself, does this stop at some point? Are there only a finite number, like let's say 1,000 of these? Or does this go on infinitely? So a guy named Euclid, many years ago, came up with this really nice proof. So what we're going to do is go through a proof showing that there are in fact a lot of prime numbers. So let's assume there's only a finite number of them. Now this is going to be called a proof by contradiction. What that means is we're going to make an assumption and show that that assumption fails. So therefore we will contradict our initial assumption. Alright, so let's assume there's a finite number. So there's your first prime number, which we'll call P sub 1 or P1, the first prime. That's 2, second prime is 3, the third prime is 5, and so forth. So let's say the largest known prime number is the nth prime number, which is some number, doesn't matter what it is. So we're assuming there are only n prime number. In other words, there is nothing past this point. So what we're going to do, and what Euclid did a long time ago, is show that that's a bad assumption. We're going to create a number, let's call it k. So we're going to multiply all of the existing prime numbers. So this would be 2 times 3 times 5 times whatever that is. Now clearly this number is not a prime number because it has a ton of factors. So it's divisible by 2, it's divisible by 3, it's divisible by 5. In fact, it's divisible by all the known prime numbers. And so what we're going to do is add 1. Now, a lot of you already get this, but what this is going to do is this will break this divisibility by all of the existing prime numbers. So for example, this number as it is divisible by 2, but as soon as you add 1, it's no longer divisible by 2. This number is divisible by 3, but as soon as you add 1, it's 1 more than a multiple of 3, so it's not divisible by 3. So in fact, this is not divisible by any of the known prime numbers. So what we've created is a new prime number, which we'll call the n plus 1 or n plus first prime number. So let's say this was the 100th prime number. This would be the 101st prime number. So this shows that if you thought there was only a finite amount, you can create an additional prime number. So this means that there are an infinite amount, or we write infinity as an upside down, as a flipped over 8. So there is an infinite amount of prime numbers, because if you assume it stops, you can create a new prime number.